Hello, here we're going to be going over the 9.4 9.5 quiz. Question 1. When using the zero product property, you set your two factors equal to. Now, what this is talking about is whenever we're given a quadratic expression, we always want it equal to 0 when we're solving for our solutions, because our solutions are really just x-intercepts, which are some x value, comma, 0. So that's why we want it set up equal to 0 so that we can solve for x. And then what we did was we'd factor it into its two pieces. And the zero product property is where you then take both pieces and set them up equal to 0. And then you'd solve. So this one says, use the zero product property, solve by factoring. The first step on this is to actually factor it. This is the easy type, so it'll start off x and x. I'm looking for factors of 2 that also add to 3 because I'm on the easy type. So that would be a positive 2 and a positive 1. Now, a trick answer is A. A is not correct. Sometimes people will pick that because they see their 2 and their 1. But we now need to use the zero product property and set them both up equal to 0 and then solve. So the actual answer on this is C, of negative 2 and negative 1. And remember that what this is telling us are the two spots that it crosses over the x-axis, this U-shaped curve. So this says, once again, solve using the zero product property. It's another factoring problem. And it's the easy type once again, because there's a 1 in front of the x squared. So we start off x and x. Looking for factors of 12 that also add to negative 8. And that would be a negative 6 and a negative 2. Because negative 6 times negative 2 gives me the positive 12. But also negative 6 plus negative 2 adds together to give me the negative 8. So, once we have that, we'll use the zero product property and set both pieces up equal to 0, and then solve. So this answer ends up being B. And once again, you'll see part of the trick answer, for something like D, because you might see that negative 2, and we have a negative 2 there. But remember, you have to use the zero product property before you can start to look at answers. So here's a final zero product property problem, but what made this one more tricky is that when you go to factor it, it is the more difficult type because of that 2, so I have to start off 2x and x. So now I'm still looking for factors of 5, so 1 and 5 are the only options, but it needs to be a negative 5, so one needs to be positive and one needs to be negative, and I have to set them up just right so that when I use the FOIL method, that is, I call it the smiley face method here, that those two orange parts combine together to give me a positive 3. And the correct combination on this is a minus 1 there and a plus 5 there. Because 2x times negative 1 is negative 2x, 5 times x is 5x, and negative 2x plus 5x does give us that middle term of 3x like we want. So this is the correct factoring, which means that's what we'll want to set up equal to 0. So once we have that there, on this one we'd subtract 5 from both sides, and then we'd divide by 2. On this one here, we would add 1 onto both sides and get that our answers are negative 5 over 2 and a positive 1. Now, another way that we had talked about factoring these more difficult type was to multiply the first and the last term together, which would give us a negative 10. And then look for factors of negative 10 that add up to the 3x, which would be 5 and negative 2. And then we'd have to rewrite those back in either order, like that, and then factor by grouping. The first 2 is an x. The second set is a negative 1. And then you write out the final answer to where the GCFs you took out form a piece, and the piece that showed up twice forms a piece. And you'll see that this factoring is the same factoring as that right there. And then you could use the zero product property on it. Question 5, I got moved over here. Find the value of c that makes this a perfect square trinomial. So this is shifting gears out of factoring and into completing the square. And the whole purpose of completing the square was to get this piece right here ready so that it can factor to the same thing twice. Right? And the way we did that was we had a formula. It was b divided by 2, and then we'd square it to find that c value. So what we'd have to do on this one is that if we took the negative 10 and we divided it by 2, we would get a negative 5. Negative 5 squared is a 25. So the answer here is 25. Another way you can do this is to write it out like this. If we go ahead and split the negative 10 up into 2 equal pieces, you'll see that you get x minus 5 and x minus 5. And then x minus 5 squared, that negative 5, when we square it, gives me that same answer as the 25. So this one says solve by taking the square root of each side. And that's why it's important to get completing the squares into a form like this so that we can solve with square roots. And what square roots did was allowed us to cancel out squares. So here we get x minus 12 is equal to, but anytime we take a square root in an equation context, we have to use a plus or minus symbol. And the reason for that is these quadratics are symmetrical, right? They make a U-shaped curve. So they'll get both a positive and a negative answer whenever we're taking our square roots. So the square root of 36 isn't just a positive 6, but also a negative 6. Which really means on this we're going to have 2 different equations to solve. Both the positive and the negative case. So when I add 12 to both sides, we'll get an 18. When I add 12 to both sides here, we'll get a 6. So that gives us our answer of B. Now up here I talked about for the plus or minus how you'll get, one positive, one negative. It can also be one like this where we had 6 and 18. It doesn't necessarily have to be one positive and one negative like this picture, but whenever we're taking a square root, we do have to consider the positive and the negative version of its answer. So this one here says which equation can be used to solve that by completing the square. So completing the square is tough, right? We had talked about that in the previous videos. What you have to do first on completing the square is move the c term to the other side. So in this case, adding 2. And then you leave yourself some space here so that we can find what number needs to go there. And to find what number needs to go there, we use b divided by 2 squared. And in this case, our b is 2. So that would give us 3 squared, which is equal to 9. So that means this missing number is a plus 9. But what I add to one side, I must also add to the other. So now we're equal to 11. And if you think about it, this should now factor to b plus 3 and b plus 3. Because 3 times 3 is 9, and 3 plus 3 is 6. And that takes us down here to b plus 3 squared is equal to 11. And that's where you see the correct answer there for H. So finally, it says which step is not performed in the process of solving this by completing this square. So let's just go through piece by piece here. Subtract 5 from both sides. Yes, we definitely need to do that because clearing the C value is the first step. So it's not A. We have to subtract 5 from both sides to get it ready. Let's check with C. It says add 16 to each side. That's also correct because when I do my formula, which is b divided by 2 squared, we get 4 squared, which means we need to add a 16 here and a 16 here, which then allows us to factor this to r plus 4, giving us r plus 4 squared. So it's not C. D will also have to do because D is now the next step here. We would now take the square root of both sides. The correct answer is B. We don't factor this right here. We don't factor it because we have to wait to find what that number is first before we factor. So you never just factor a two-term piece when completing the square. You have to use your formula to find that missing number there in red and then factor it.